Hello! In this video we're going to be going through a full GCSE workpack that I've created on sectors. So before we start, I just wanted to say that this workpack is available to download on my website, so I will link that in the description box below. So if you wanted to have a go at some of the questions before we go through some of the answers, then feel free to do so. You can also see my full worked solutions as well. But otherwise, let's get started. We start from question 1. So it says the diagram shows a sector of a circle with centre O. The radius is 7 centimetres and the angle is 60 degrees. We need to calculate the area of the sector, giving our answer in terms of pi. So for this, we need to recall that to find the area of a sector is just a fraction of a circle. So the fraction of the circle that it makes up is determined by the angle. So it's the angle over 360, because there's 360 degrees around a point, times pi r squared. So we're going to do x over 360, which is the angle over 360, times pi r squared. So that's going to be the area of the sector. So in this case, x is 60, so it's going to be 60 over 360 times by pi times by 7 squared. Now I'm going to simplify 60 over 360 because I know that simplifies to 1 over 6. So it's going to be 1 over 6 times pi times 49. Now 49 times 1 over 6, because 49 by itself is 49 over 1, we can write this as 49 over 6 pi, and that is the answer to this question. So this next one here, it says the diagram shows a sector of a circle with centre O. The radius is 10 centimetres and the angle is 72 degrees. We need to find the length of the arc. So again, the arc length is just a fraction of the circumference of a circle. So the circumference of a circle is given by 2 pi r. So the arc length is going to be whatever the angle over 360 is, so the fraction of the circle that we have, times 2 pi r. So the arc length we give as x over 360 times by 2 pi r. So in this case, the angle is 72. So we have 72 over 360 times by 2 pi times by 10. So in this case, 72 over 360, that simplifies to 1 over 5. And then we're timesing it by 2 pi and then timesing it by 10. Now 1 over 5 times 10 is just 2, so we have 2 times 2 pi, and 2 times 2 pi is equal to 4 pi. So the answer to this question is 4 pi. This next one here, it says the diagram shows a sector of a circle with radius of 8 centimetres and an angle of 135 degrees. We need to calculate the area of the sector. So again, the area of a sector is x over 360 times pi r squared. So the area is equal to x over 360 times pi r squared. So in this case, we have the angle is 135. So 135 over 360 times by pi times by 8 squared. Now this one, it doesn't say whether to give it in terms of pi or to leave our answer to a certain number of decimal places. So I'm just going to leave it to 3 significant figures. So if I type this into my calculator, I end up with 75.398. So if I give that to 3 significant figures, that's going to be 75.4, and that's in centimetres squared. So the answer to this one is 75.4 squared centimetres. The next part, we need to work out the perimeter. So the perimeter means all the way around the edge of the shape. So we need to know what this length is, we need to know what this length is, and we need to know what the arc length is. Now we already know what the radius is. The radius is 8, and because the radius around a circle is consistent, we have this length is also 8 centimetres. So all we really need to work out is the arc length. And to work out the arc length, we do x over 360 times by 2 pi r. So in this case, it's going to be 135 over 360 times by 2 pi times by 8. So if I work that out on my calculator, I end up with 18.85 centimetres. So the arc length is 18.85 centimetres, which means that the total perimeter is going to be 18.85 plus 8 plus 8. And if I work that out, I end up with 34.85 centimetres. So if I give that to 3 significant figures, that's going to give us 34.9 centimetres, and that is the answer to 3 significant figures. This next one here, we're told that the diagram shows a sector with radius of 5 centimetres. The area is 20 pi. We need to find the length of the arc. So we know that the area is 20 pi. So we can work backwards to work out what the radius must have been by substituting that into the formula for the area of a sector. So the area of a sector is x over 360 times by pi r squared. So the area is 20 pi. And that is equal to x over 360 times by pi times by 5 squared. So then the pi and the pi cancel out, so the pi and the pi cancel. So we have 20 equals x over 360 times by 25. So now what I can do is I can divide both sides by 25, and I have 20 over 25 equals x over 360. And now multiplying both sides by 360, I end up with x equals 20 over 25 times by 360, and the answer to that is going to be 288. So the angle must be 288 degrees, so we can clearly see that this diagram has not been drawn accurately, but that doesn't matter. So we have 288 degrees. So to work out the arc length, we have x over 360 times by 2 pi r. So in this case, it's going to be 288 over 360 times by 2 pi times by 5. So if I type that all into my calculator, I end up with 25.1 centimeters. So the arc length is 25.1 centimeters. This next question here, we have a sector with radius of 9 centimeters. The length of the arc is 6 pi. We need to work out the size of the angle. So again, it's one of these questions where we need to work backwards. So the arc length, the formula for arc length is x over 360 times by 2 pi r. So if the arc length is 6 pi, we have 6 pi equals x over 360 times by 2 pi times by 9. So now what we're going to do is times both sides by 360 to get rid of the divide by 360. So 360 times by 6 is going to be 2,160. So we have 2,160 pi equals x times 2 pi times 9. So we can divide both sides by pi because the pi's cancel. So we have 2,160 equals x times 2 times 9. So 2 times 9 is 18, so that's going to be 18x, and this is going to be 2,160. So dividing both sides by 18, we have 2,160 divided by 18, and the answer to that is 120. So x is going to be 120 degrees. This next question here, it says the diagram below shows a sector centre O, the radius is 12 centimetres and the angle is 120. OAB is formed by joining the radii. Calculate the area of the shaded region between the arc and the triangle OAB. So essentially we're trying to work out this region here. So in order to do this, what we're doing is removing a triangle from a sector. So we have a sector minus a triangle, and that gives us the shaded region. So we need to work out the area of the sector, the area of the triangle, and then subtract them to get the shaded region. So to work out the area of this triangle, we can use the formula half AB sine C. We can't necessarily at this stage use the half times base times height formula because at this point we don't have the perpendicular height. So it's going to be easier to use the area is equal to half AB sine C. So we have half times A times B. So because the radius is the same on both sides, we have times 12 times sine of C, which is the angle, which is 120. So we have half times 12 times sine of 120. So that's going to be 62.35. So that is going to be the area of the triangle. To work out the area of the sector, we're going to do x over 360 times by pi r squared. So that's going to be 120 over 360 times by pi times by 12 squared. So if I type that into my calculator, I get 150.80 if I round that to 2 decimal places. So the shaded region is going to be 150.80 minus 62.35, and if I type that into my calculator, I end up with 88.45. So the answer to this question is 88.45, and if I want to give that to 3 significant figures, that's going to be 88.5 centimeters squared. So that is the answer to this question. This is the next one. So the diagram shows a rectangular garden ABCD. We have AB is 20 meters, so I'm just going to mark that one as 20 meters, and BC is 12 meters. The shaded region will be covered with some artificial grass, and artificial grass is sold in packs that will each cover 8 meters squared. Each patch costs £45. Calculate the cost of covering the shaded region, giving your answer to the nearest pound. So essentially we need to work out the area of the shaded region. We then need to divide that by 8 meters squared to figure out how many packs we need, and then times that by 45 to work out the total cost. So to work out the area of the shaded region, I need to first work out the area of this sector and the area of the rectangle and subtract them. So to work out the area of the sector, I know the angle, this angle is 90 degrees because it's a right angle. So it's going to be 90 over 360 times by pi times by 12 squared. So if I work that out, that's going to be 36 pi. And the area of the rectangle, we're just going to do base times height. So the area of the rectangle is going to be 20 times by 12, so that's 240. So then the area of the shaded region, if I subtract them, I'm going to get 240 take away 36 pi. So that's the area of the shaded region. So if I work that out, that is going to be 126.9 meters squared. So we have 126.9 meters squared is the area of the shaded region. Grass is sold in packs that cover 8 meters squared. So we need to work out how many packs we need. So we're going to do 126.9 divided by 8 to work out the number of packs. So if we do this, we end up with 15.86. Now we can't buy 15.86 packs. We're going to have to buy 16 packs. And each pack costs £45. So the total cost is going to be 16 times by 45, and if I work that out, we end up with £720. So the answer to this question is £720. Okay, so that's everything I have for this video. So thank you so much for watching. Again, the full workpack and written solutions is available on my website, so see the description below. But otherwise, thank you so much for watching, and I'll see you again in another video. Bye!